Hello, Tech Pros. Let's be real here for a minute. I'm sure a lot of you have been in this situation yourselves, and you definitely understand the pain of this situation. So, here's what's up. You have a production outage, you have angry and disappointed users sending in bug reports and emails. The company leadership is pressurizing you to resolve this issue ASAP. It's late in the night, you get pulled into a call, and you realize you have to dive headfirst into a sea of logs. But where are the logs? Your application probably has multiple services, multiple containers, and even maybe multiple virtual machines. And you realize you have to SSH into all these different machines, open up these services, and then look at all the logs in the terminal. And you're left grepping at logs in the terminal. That's painful, I know. Sounds familiar though, right? I know it does. I've been there myself. So what was the real problem here? Well, the real problem here is that you did not pay attention to setting up an observability stack for your application. You did not set up centralized logging. And even if you did have somewhat of a decent level of logging, you maybe did not pay attention to setting up a querying and filtering ability on these logs, leading you to grep at logs in the terminal. And you most likely did not follow a standardized formatting for your logs either. Sounds like a mess, yeah. But don't worry, I got your back. In this video, we'll learn how to fix these issues once and for all. We'll set up Loki as our centralized log aggregator. Then we'll set up Grafana for us to be able to visualize and query these logs. And for demonstration, we'll be working with TypeScript, Node.js, and we'll use Winston as our logging library of choice. Before we jump into the code, let's look at the basic system architecture. So this is how a simplified architectural diagram for this looks like. Let's assume we have n different services. These can be different virtual machines, these can be different containers, different services, these can be different deployment as well. We need to concern ourselves with the fact that these entities generate a lot of logs, and we need to transport those logs to Loki, which is our centralized log aggregator. What Loki is going to do is index the metadata, compress them into small chunks, and ship them over to a cloud-based storage service or to a file system, but generally a cloud-based storage service is recommended, not the file system, unless you are very good at setting up the rotation logic for those files. Lastly, we have Grafana. This makes our life easier because it lets us visualize those logs and easily query all these logs, and it provides us a very intuitive graphical user interface. Now we're ready to jump into the code. So we have a very basic Nest.js application. We're going to use Docker Compose to set up our environment. So we have three services. One is our main application, second is Loki, and the third is Grafana. We're using their official images from Docker Hub. In the ideal case, you don't want to hard code your secrets. For demonstration purposes, I placed them here. You ideally want to pull them through a secrets manager service, or at least use like a dedicated environment file and inject those variables through that file. Pay attention to the volumes and the command feature. We mount a volume where we're taking up this file, lokiconfig.yaml, which is present in this directory, and we're mounting it to this directory within the Docker container for Loki. And this command basically tells Loki where to look for the configuration file, which is at the exact same path where we mounted our volume. That's pretty much it. This is a very basic setup. Again, like the Docker file for our Nest.js app, very bare bones. Let's analyze the Loki configuration. Now I took this configuration directly from the documentation provided by Loki itself. What we need to pay attention here is how we configured our storage service for our logs. We simply provide these values, and Loki does the rest. Also pay attention to this ingester. These are not the default settings. I've set them to be very low so that Loki pushes all these logs to S3 very quickly at max of 10 seconds of the period. So it will not hold any logs in memory for more than 10 seconds, and it'll just ship them off to AWS S3. Other thing you need to pay attention to is that listening to port, we're running Loki on port 3100, which was the case in the Docker file as well. Now that the setup is clear, let's look at the code. So we'll start off with how we build our logger. So we're going to use Winston package and Winston Loki package. Winston is a standard logger. Winston Loki provides us with Loki transport. What it does is basically picks up all these logs and it ships them off to Loki. If you don't want to use this, you can use Promtail as well, which is advised by the documentation provided by Loki as well. So we specify the host. We do not write localhost, we write the name of the Docker container running it. So Loki at 3100, and then we specify that JSON is true. Then we define like the configuration of our logger. We specify that all the logs which are of level info and above, that is error and warning, all these logs are going to be logged. Then we specify a basic format. We combine timestamps. We want our errors to show up with their stack trace. We want JSON logging. JSON logging makes it easier for us to query, and it's part of structured logging. We should follow this in production. And then this pretty print part is basically for us to be able to read it on a console, makes it more human readable. Default meta, this is some information that we attach to the logger. This will always be present there. We can add more stuff to it, as we'll see later down in the video. Then we specify the transports. Now we want our logs to show up on the console, which is the standard out, and the Loki transport, which we defined above. Then exception handler and rejection handler. These are basically any uncaught exceptions that might bubble up that might not get caught by the Nest.js runtime. They will also be shipped off to Loki transport, and rejection handler takes care of any uncaught promises that got rejected. Then we basically create this logger and now we export it. But this is a very static logger. We want to make sure that our logger is dynamic, such that every new request that comes in, we want that specific information to be attached to our logger as well. We make it happen through making a logger service that is request scoped. So all services in Nest.js by default are singleton. That means only one instance of that class exists. But in our case, for this logging service, we want it to be request scoped. So whenever a request comes in and wherever this logging service is a dependency, that class will create a unique instance of this class for that specific request. And once that request is over, this instance will be discarded by the Nest.js runtime. So basically, we inject the request object in the constructor, and through that we populate the logger's default meta. Now each specific request is going to have a unique request ID, which we generate through using this UUID package. So ideally this user ID should be populated by your authentication middleware, but for simplicity purposes we're going to be sending it in our headers. But just so you get the idea, we inject the request object in this logging service. So we get unique request parameters and we add that to the logger's default meta. Now this logger is going to be specific to this particular request only. And then since we are implementing the logger service, which came from Nest.js Common, we define all these methods so that it implements it properly. Now we have a dynamic logging service set up. Let's see it in action. I'm starting the application through Docker Compose, and looks like we're ready to go. Yep, Grafana, Loki, and my Nest.js application are up and running. Perfect. So I have created basically 2 endpoints to show it. So we'll start off with the post, this post endpoint. All it does is call this dummy process from this request. In this service, you can see in the constructor, we are injecting the logging service. This is standard dependency injection stuff upon which Nest.js is built. And what this method does is it simply logs out an info level log and then it throws an error. But since it's an Since it's in a try catch block, then we catch that error and then we log it at the error level. I'll just quickly send out a post request. Cool. So as you can see, like, we have our request logged here. Now we'll see Grafana in action. Once you open Grafana, you're going to have to log in. The email password is going to be admin. This is the default. You can change it later if you want to, or just skip it. Now the first thing that you have to do is create a data source, which is basically we are connecting Grafana with our Loki. So you open up the menu. In Connections tab, this is the Connections tab, you add a data source. Now by default, Loki might show up here, it may not. I'm just going to delete this so I can show it to you again. Most probably, this is what's going to show up. You just add a data source, you look for Loki, cool. And then in the path, if you're running it with Docker Compose, do not use localhost, use the name of the Docker container on which Loki is running. It was named Loki in my case, so I just put in Loki, port 3100, and then you just, all right, connected successfully. Now we shall go to the Explore tab. Here, select the Loki data source. Now we have to look for labels. We have to assume that the logs were already sent in. So since I did send in a couple of logs, I set the level as info. And then I just run the query. So in the last 5 minutes, we had this request come in. Now you can just see how it's filtered out. Again, let's say we had a user ID of 420. I want to query it by user ID. As you can see, like, Loki understands that these are the different parameters upon which filtration is possible. So I have user ID coming in and it already supports this 420 variable, this 420 value. And then we have two values. One is an error and one is a log. So if you remember, at the code level, we threw this log, we threw this error, and then we logged it. So if you look at the error, we get the proper error with the stack trace, with the user ID, with the request ID. So you can see like how easy it makes us to investigate like what went wrong at any level. Now we'll send in a request with another user ID. Let's say this is user ID 123. Let's make it a GET request this time. We send it. So this is the GET endpoint. This is where we throw an error we reject a promise basically, and then we catch it. So I come here, I shall be able to filter it out by user ID. See, now we have another user ID showing up. So this is the magic of Loki and Grafana. I simply run this and then I get this error which was logged. Now I can investigate easily by looking at the stack trace. Makes my life so much easy as a developer. Just to show you how it's connected with S3, if I open this bucket, you can see Loki has created all of these files. Let me just refresh it once. Okay, we have 3 entries. Now this fake directory, this is created because we're running Loki in a single tenant mode. If we were running it in multi-tenant mode, we'll have other directories which had the name of the tenant. So Loki basically pushes all of the data in this bucket, and then whenever we're running a query, it queries the data present here and in its memory, and then we see it in Grafana. So that's how you can implement centralized logging and filter and query over it using Grafana. Thank you for your attention. I hope you enjoyed this video. If you think this video added value to your life as a software engineer, consider giving me a thumbs up and consider subscribing. I will be creating a lot more videos in the future. Stay tuned. Bye bye.